This video is for class 9 physics, and in this video we shall do experiment number 1 from your practicals, according to which we are supposed to find the least count of a vernier caliper, measure the length and diameter of a given cylindrical rod. So basically we are doing three things in this experiment. We are trying to find the least count, we are trying to measure the length and the diameter of the small cylindrical rod. The apparatus therefore will be vernier calipers and a small cylinder whose length and diameter needs to be measured. Okay, now why to measure the length and diameter with the help of vernier calipers? It can be done with the help of a simple ruler also. We are using the vernier calipers in order to increase the accuracy. Okay, now how the accuracy can be increased? Because as you all know what least count is, right? As you all know what least count is, this count is the least or the minimum or the smallest measurement taken by a measuring instrument. So a ruler can measure up to 1 millimeter only, but the least count of the vernier calipers will be less than that, so therefore it is more accurate. So if you go to the theory part, right, the least count of vernier calipers is the smallest length which it can measure, which will be up to 0.01 centimeter, right, less than 1 millimeter, that is 0.1 millimeter. To find the least count we are supposed to use this formula. We shall use this particular formula afterwards, right. This formula says that to find the least count of a vernier caliper we are supposed to divide one division in the main scale. Remember, this is the main scale, right, and total number of divisions on the vernier scale. Here we have the vernier scale. So let us try to understand the parts of the vernier calipers. To understand the parts of a vernier caliper, here we have the figure. Probably you have drawn this figure on the blank side of your practical file. So here we have inside jaws. This is used to measure the inner diameter of a pipe or a mouth of a bottle from inside, etc. Now this is the outside jaws. The outside jaws are used to measure the outer diameter of the object or outer length of the object. You can see this light blue part is the fixed jaw. Okay, now the dark blue part here is the movable jaw. It can be moved, right, with the help of one screw placed just below it, which is not shown in the figure, right, and there's a screw here at the top. This will ensure the tightening or the movement of this particular scale, that is the vernier scale, right. So the vernier scale starts from 0, ends at 10, right, and this is the main scale. It is measured in centimeter, right. So there's a strip here at the back of the vernier caliper. This is also used to measure the depth of particular pipe or bottle, etc., but we are not going into that detail, right. So let us understand the real vernier calipers, okay, and try to find the least count of the vernier calipers, right. So let us go to that particular part. So we have a real vernier calipers here, right. Here in the vernier caliper, here you can see here, you can see one particular kind of a wheel. This wheel is used to move this vernier, right, and we have a screw at the top. This screw is used to tighten this particular part, tighten this particular part so that it does not move easily, it does not slide over the main scale easily. Now this is the main scale. You can compare it with your book diagram also, right. These are the inner jaws here and these are the outer jaws. These are the main parts, right. So let us try to understand more about this particular vernier caliper and try to calculate its least count also. Now we have the main scale. We can see the verniers, right. The vernier starts from 0 and there are 10 of them. Okay, there are, you can count it, there are 10 of them. It always needs to start from 0 to 10, right. Then you can see you have this outside jaws, and this is the inside jaw, right. This is used to measure the inner diameter of a pipe I have taken a pipe, and this is how it is used to measure the inner diameter, but we are not measuring the inner diameter, remember. Okay, and if it is not visible properly, you can check out, right? So, and then I'm using this particular screw to open and close the jaws. So here the outside jaws are used to measure the outer diameter in this fashion, right? So now let us try to find the least count of the vernier calipers. Here you can see this screw is being used to adjust this particular vernier part, okay, and I'm using this particular screw to move, right? So now let us try to find out the least count of this particular vernier caliper, right? To find the least count, I'm supposed to know the total number of divisions on the vernier scale. Total number of divisions on the vernier scale. If you count the total number of divisions on the vernier scale, if it is visible here, you can see here starts from 0, right? If you count it, okay, right, and it will end at 10. So how many do you have? 10. So I have written 10 out there. Now the value of the one main scale division, that is x here, that is the distance between, okay, I think I need to put the vernier calipper a little bit at the top. Okay, now you can see the distance between this point and this point here should be 0.1 centimeter, right? Should be 0.1 centimeter. Therefore the least count will be x upon n, that is I have written x here and I have written n here. Okay, so x is 0.1 and n is 10 here, you can see here. So if I divide this, I should get 0.01 centimeter, right? 0.01 centimeter. So I hope you have understood how to find the least count of the vernier. Now let us try to use these vernier calipers to find the length of the rod. So here I have taken a glue stick, right, and I'm trying to find the length of this particular glue stick with the help of vernier calipers. So with the help of this adjusting screw, I have just moved my outer jaws and I'm trying to fix this particular glue stick in between the outside jaws. Once I have fixed it, right, once I have fixed the glue stick in the outside jaws, I'm trying to check out this particular 0 mark of the vernier, and you can see here the 0 mark is in between 7.9 and 8. It has not reached 8, so I have to take the lower value, which is, I need to take the lower value, which is 7.9. I need to take the lower value, which is here 7.9, this value here, right? Now my duty is to find the vernier scale also. To find the vernier scale, right, I'm supposed to find a line on the vernier scale. I'm supposed to find the mark or the marking on the vernier scale such that it is exactly matching with the upper main scale reading in this way. Here in this particular clip, you can see here, okay, there are so many lines in the vernier scale and there are so many on the main scale. If you see the fourth one is exactly aligned with the upper reading. The fourth one is exactly aligned with the upper reading. But here you can see there are others also, okay, like this here, they are not aligned, okay. But in the fourth one, if you see there, it is aligned with the main scale. So my vernier reading, my vernier division coinciding with the main scale division is the fourth one, right? Did you understand the concept? I hope you have understood the concept, right, of finding out the vernier scale, right, of finding out the vernier scale. So here you can see the fourth one is matching. Since the fourth one is matching or coinciding with the main scale, right, the fourth one is coinciding with the main scale, so I'll write 4, okay, multiplied by 0.01, because I am supposed to multiply with the least count, which will be giving me 0.04, right, which shall give me 0.04. Now the total reading will be main scale reading plus the vernier scale reading, which shall give me 7.94, which shall give me 7.94. Now similarly, I have taken other readings as well. I have taken the second one and the third one. Here you can see the main scale reading will not change. The main scale reading of a given object will not change. It should remain same. Now only the vernier divisions will change, because these are very minute, okay. So only the vernier will change, okay, but the main scale will not change. So here in the first case I got 4, in the second case I got 2, in the third case I got 3, right. So here also I am multiplying this vernier division with the least count, so I shall get 0.02. then I am also multiplying the third reading and 3 multiplied by 0.01 with the least count, again I am getting 0.03. thus this total reading will be, the first one I have already shown you, which is 7.94, the second one will be 7.92, and the third one will be 7.93. so I am supposed to find the mean length. Please do this part on the blank side of your practical file with the pencil only, right, pencil only on blank side, okay, on blank side, right, the calculation part, this part, right. So here 7.94, 7.92 and 7.93 needs to be added to find the mean, means to find the average. I hope you know how to find the average. If I add all these three things, I shall get 23.79 upon 3, right. If I divide this here, I shall get 7.93 centimeter. I am getting 7.93 centimeter. In some cases there might be other decimal points also, but in our case we are just getting 2 decimal places, hence so I am writing the final answer as 7.93 centimeter. So up to 3 significant digits, here we have only 2, so that is enough. That's how we are supposed to find the length of the rod. So what's the length of the rod? The length of the rod is 7.93 centimeter, right. This is how we are supposed to find the length of the rod. Let us try to find the diameter of the given cylinder. Now to find the diameter of the given cylinder, right, I am repeating the same process. Here we are trying to find the diameter of the given cylinder. So here you can see there are so many readings in your table. There are total 6 observations, right, 1 2 3 4 5 and 6. So we are taking the readings in these 3 different positions. First position on one direction, in the other direction. Then if it's not clear, you can see from here also in the second position, right, in this direction and in the perpendicular direction also. Now here I have used a similar method. Here you can see here, right, what is the main scale reading? It is matching with 2, hence the main scale reading will be 2. The main scale reading will be 2, right. And let us check out the vernier scale also, like before. If you see the first one here, the first one is matching, right. If the first one is matching, hence my vernier scale will be 1 multiplied by the least count. You need to take the minimum value, the first one which is matching, right. So 1 is matching, so I am taking 1, right. So here I am taking 1 multiplied by the least count, which is 0.01, will be giving me 0.01 centimeter, isn't it? So what will be my total reading? My total reading shall be this particular value plus this particular value, right. So main scale plus the vernier scale. So if I add them, I am getting 2.01. I am getting 2.0. Similarly, I have taken the other readings also at the different places of the object. So total we have 6 readings now. As you can see, the main scale reading did not change, right, whereas the vernier scale readings are changing a bit. These changes are because of the small deformations or the uneven surfaces present on the object given to us. Now I have used the previous steps to get to my final answer. First thing what I have done is I have multiplied each vernier divisions by the least count, right. thus arriving to this particular vernier scale reading. Then I have added the main scale reading with the vernier scale reading to get the total reading, right, and I have 6 of them. Now I am supposed to find the mean diameter or the average diameter. To find the mean diameter, I am supposed to add all these total readings, okay, where I have added, and I arrived to the answer 12.09. Now this 12.09 needs to be divided by 6, as there were 6 different observations, right. So after dividing the number by 6, I am getting 2.015 centimeter, right. So my final answer will be 2.015 centimeter. Therefore the result of the experiment, okay, is least count of the given vernier calipers, which we had determined earlier, which is 0.01 centimeter, the length of the given cylindrical rod, that is 7.93 centimeter, and the diameter of the cylindrical rod, which is 2.015 centimeter. These were the 3 objectives which I need to fulfill while doing the experiment. So I hope you have understood the experiment. Thank you so much.